All right, good morning or good afternoon. Happy Wednesday. Good to see you all. All right, couple of announcements. First of all, the review 3.3, which we actually did in Math Wizard Teams, is due tonight. And we have an exam 3.3 on Friday morning at 8. So yesterday I talked about the circle 4.1. It's due on Thursday night. And today I'm going to teach 5.1. So at the beginning of next week, depending on when you have class, Monday or Tuesday, you're going to take exam 4.1, 5.1 during the class time. So in other words, you will not report to the class meeting. You will go straight to my HRW like you normally do to take an exam, depending when your class is Monday or Tuesday. Okay, so I'm going to repeat that. Exam 3.3 is on Friday at 8 a.m. On Monday or Tuesday, depending on when your class is, you're not coming to the class meeting. You're going to go to my HRW and take exam 4.1, 5.1 during the class period. All right? All right. Now, you might be wondering, why are we taking a test so early after 3.3? Because I feel like the circle is fairly easy. And this new 5.1 is just graphing the cubic polynomial like we graphed the quadratic. So I don't even really have that much new to show you. All you're going to do is graph the cubic. And you're going to write equations for the cubic. So do you guys have any questions for me about anything right now? Because it's going to take, we're in that weird Wednesday schedule. So I'm going to spend most of the period teaching 5.1. Anybody have any pressing questions for me? If you do want me to work any problems, like last night I was working some problems with some students. All they did was send me a remind and I worked some problems in a Google Meet. So feel free to contact me if you want to work any problems or do something. All right, can I start on lesson 5.1 then?
Yeah.
Oh, and then by the way, tomorrow we're going to spend almost the entire period doing a review for 5.1. There is no review for 4.1. So the review for 5.1 we're going to do together in the Math Wizard Teams tomorrow. So in 5.1, we're going to look at graphing cubic functions. This is California Common Core Standard F-BF.3. And so let's look at the parent of the cubic. He's the most basic graph. Down one, put in a 0, 0 cubed is 0, put in a 1, 1 cubed is 1. So those are going to be our parent points. They're a little different than the quadratic. Left down 1, 0, 0, right 1, up 1. Do not draw a line. The cubic does look like a snake up and down. So it's going to go like this. Up and down. So we're going to do transformations just like what we did before. Remember, you have to state the correct order, right? Remember, the order for Form 1 is left, right, stretches and compressions, reflections up and down. So how would you state the order here? Go ahead, I'm listening. How do you state the order? Still waiting. We spent a lot of time looking at A, B, H, and K, so I'm not going to reteach it. So please give me the order of the transformation of the cubic.
Left one.
Left one.
Vertical stretch of 2.
And
Down 3.
so here we go. Just remember that left and right, you're just adding and subtracting to the X and Y. Remember the stretches and compressions, you're multiplying to the X or Y. Remember, everything outside the cube is vertical Y. Everything inside the cube has to do with horizontal X. So left means -1 to the X, -1 to the X, -1 to the X. The Y stays the same. Vertical stretch means multiply the Y, vertical. Multiply the Y, so the X stays the same. Multiply the Y by 2, multiply the Y by 2, multiply the Y by 2. Down means subtract 3 from the Y. So subtract, so keep the X the same. So subtract 3 would be -5. Subtract 3 would be -3. And subtract 3 would be -1. And then that's it. You graph it. All right. So we have left 2, down 5. We have left 1, down 3. We have 0, down 1, and do not draw a line. So this is a cubic. And the domain, by the way, is always all real numbers left and right. And the range is always all real numbers up and down. So this is an easy domain and range. So it does look like it was shifted left. It does look like it was vertically stretched, and it does look like it was shifted down. All right, any questions about transformations? Now, I put some practice problems in the assignment, but they're not part of the assignment. It's just an extra sheet for extra practice. Questions about this? Okay, can I erase this? Are you guys still writing?
I'm done.
All right. Remember back in 1.1, we had to do the characteristics of graphs. Remember, we had to do domain, range, and behavior. We had to do positive, negative, decreasing, increasing, x-intercepts, y-intercepts. Remember all that?
Yeah.
Well, it's come back now. I think it's the first problem in the 5.1 part of the test. So they're going to give you a graph. And you have to state the characteristics. So in this case, they're giving you the parent. Of the cubic. And the first thing they want is the domain and range. So go ahead. What's the domain and range? Go ahead, I'm listening.
Is it negative infinity to infinity?
Yeah, it's forever left and right. Range. Sometime this year, the range.
It's also negative infinity to positive.
Forever up and down. So forever left and right, forever up and down. Okay, let's look at the end behavior. As x goes to the right forever, what's y doing? As x goes to the right forever, what is y doing?
Infinity?
Going up forever. As x goes to the left forever, what is y doing?
Negative infinity.
Forever.
Right. Okay, now x and y intercepts, those are ordered pairs. So what are the points? Where's the graph crossing the x-axis? 0, 0. Where is it crossing the y-axis?
0, 0.
Okay, now remember we had positive, negative, and increasing and decreasing? So remember everyone was confused about this because you were looking up and down but giving the answer as the domain. And you have to keep these open, right? So let's start with increasing and decreasing. As you walk to the right, do you ever see the graph going down, or is the graph constantly going up?
Constantly going up.
So it's increasing everywhere. Where is it decreasing? Do you see it going down anywhere?
At 0, 0.
No. When you're walking to the right, this graph is constantly going up. You don't see this graph going down, do you? As you walk
It
to
never
the
goes
right,
down.
it never goes down. Okay, now we go to odd and even. You remember how we did this? We took the function and we put it in negative to see what we get. So this would be a negative x quantity cube, which is negative x cubed. So it's exactly opposite. Isn't that odd? When they're exactly the same, it's even, y-axis symmetry. When it's exactly opposite, it's odd, What kind of symmetry is that? Remember? Cross the y, cross the x, origin symmetry. Remember? So you have to know the characteristics of the functions. We're going to do positive and negative right now. Do you guys need me to repeat this over here with odd and even?
No.
All right. What's positive mean? Doesn't positive mean where it's above the x-axis? And remember, you're giving the domain. So where do you see it above the x-axis there? How would you state the domain? Open on what? Open on what? How do you state the domain? How do you state the
Wait,
domain?
the 0 to positive infinity?
Open on 0 to positive infinity. And what about negative? How would you state the domain right here?
Negative infinity to
Negative
0.
infinity.
Negative infinity up to 0 open. Watch your order. Okay, anybody want to ask me about any of these characteristics? Can I erase them?
Your computer.
Can I erase them?
I'm just copying it down.
Can I erase it now?
Yeah.
Yeah.
Everybody got it?
Yeah.
All right, so now we're going to look at, remember when they gave you a graph and you had to write the function? Well, now we're going to get given a graph, we're going to write the cubic polynomial function that the graph represents. The first problem I do is going to be real simple. The next one is probably going to have some questions about it. So they give you the function.
Could you move your screen up just a little bit?
And they give you a graph. So the graph is right 1 down 2. Right 2 up 1. Three up 4. Now, I recommend that you do not read the book in this, because this is confusing. I would not read the book. I would only look at your notes. So remember we found AD, H, and K? Now here's the difference. Remember when we had the quadratic, the vertex was HK. When we had absolute value, the vertex was HK. When we had the circle, it was the center that was the HK. Now at the cubic, it's the middle point. So the middle point is right to up one. What's B? What's B? What's A?
You're kind of cutting out for me a bit.
You guys hear me?
Yeah, you're just cutting out a bit.
Okay. What's B and A?
B is 1.
B is 1, and we're trying to find A. So you can use any of the other points. Use 4. That's your X. So we're going to put G of X equal to A times X minus H quantity cubed plus 1. And remember we talked about this? That G of X is actually Y. Right? And so this would be A times 1 cubed plus 1, which is 4 is equal to 1 times A plus 1. So A is equal to 3. So your equation is G of X is equal to 3 times X minus quantity cubed plus 1. Right?
Yes.
Yeah.
Okay, now this next one is a doozy, and you're going to probably have questions, but we always know we have to find B, it's harder. So can I erase this?
Yeah.
All right, here we go. So this time they give you a graph and they give you left 4, up 1. They give you left 3.5, up 2.
Could you move your camera up a bit, please?
So we're going to be working with decimals, so don't be afraid to use a calculator. And left 4.50. So it is a polynomial. And this time they give us this equation. This is the second form. And we have to find A, B, H, and K. So H and K is the middle point. So H would be what? And K is 1. What's A? What's B?
1.
We don't know. So I'm going to use negative 4.5 and 0 for my X and Y because I like the 0. And so we're going to write G of X is equal to 1 over B times X is negative 4. Quantity cubed plus 1. Now, what you see me doing here is you see me using parentheses on brackets after that, and then curly brackets. So I have 3 nested parentheses. So your G of negative 4.5 is 0. And we get 1 over B times negative 4.5 plus 4 is negative 0.5 quantity cubed plus 1. So we get is equal to negative 0.5 over quantity cubed plus 1. Subtract 1 is negative 0.5 over B quantity cubed. And now I'm going to write a proportion. So negative 0.5 cubed, negative 0.125. And B cubed is B cubed. And what I'm going to do with that is I'm going to cross multiply. So you get negative B cubed is equal to a negative 0.125. So multiply both sides by a negative 1. And now, instead of the square root of both sides, you're going to take the cube root of both sides, and you do not put plus or minus. So we're going to talk about nth roots in the future, but right now, just know that if the index is odd, you do not put plus or minus. When the index is even, you put plus or minus. Square root, fourth root, sixth root. When it's a cube root, fifth root, seventh root, don't put plus or minus. So this is, and where is the cube root on the calculator? All right, if you go to math, cube root is number 4. So you put the cube root in a 0.125 and close the parenthesis and hit enter. What'd you guys get?
0.5.
Right. Okay, now pay attention. Not over yet. The equation is going to be G of X is equal to 1 over 0.5 X minus a negative 4 quantity cubed plus 1. Now here's the problem. You cannot have a decimal or a fraction under a fraction. So this is really 0.5, right? Can't have that. So watch what I'm going to do. 1 over 0.5 is equal to 1 over 5/10. 1 over 5/10 is 1 over 1/2. And 1 divided by 1/2 is 1 times the reciprocal, which is 2. So your final answer, e of x is equal to 2 times x plus 4 quantity cubed plus 1. All right, so this right here might be confusing, so you can ask me, but you cannot leave a decimal in the denominator of a fraction. It's like leaving a fraction under a fraction. You cannot do that. It's considered not to be simplified. Okay, I will take questions on this problem. So anybody want to ask me steps?
Could you just show us how to do the 1 over 0.5 again, but like with a different decimal?
Yeah. With a different decimal?
If you can, yeah.
Well, I don't really have room, but I'll show you. 1 over 0.6. Well, 1 over 0.6 is 1 over 6/10. So if you simplify this, this is really 1 over 3/5, which is really 1 divided by 3/5, which is really 1 times 5/3, which is really 5/3.
Okay, thank you.
Other questions? All right, does everybody have this written down?
Yeah.
All right, yeah, this was probably the worst problem in the world. You may have 1 or 2 problems like this, but I mean, yeah, this is a rough one. You should be able to do it though, but it's a lot of work. All right. Okay, so now what I want to do is I want to look at some practicals on page 240. Page 240, example 3. Okay, so we have a cube of little blocks that kids play with, you know, they have the letters A, B, C, and they want to know the length of the side of a cube. Now you're going to use X. So you always use X for your variable on the calculator. So read the problem with me. It says, estimate the length of an edge of a child's alphabet block, it's a cube, that has a mass, that's the weight, of 20 grams and a density of 0.6 0.72 grams per cubic centimeter. Now, the volume of a cube, so from geometry. So you know the area is length times the width, but the volume in terms of the length, is cubed. So that's the volume of a cube. Now, the mass is equal to the density times the volume. So that's the mass of the block. Well, we know the mass is 23, and we know the density is 7.2, and we know the volume is L cubed or X cubed. So guess what we're going to do? We're going to use the graphical approach to this out. So watch. Y sub 1 on the graphing calculator, we're going to put 0.72 X cubed. And under Y sub 2, we're going to put the line Y equals 23. So let me show you what you're going to see. You're going to have a line going through the Y axis at 23. And you're going to see part of the cubic. This is not a quadratic. So this is one side of the cubic. And you're going to use the trick to use the spider and get this ordered pair, and whatever you get for X is going to be your answer. So we're not going to graph this on our paper. We're going to use the graphing calculator. We're going to mess with the window, make sure we capture Y equals 23, capture the point, and get the answer, which is going to be 3.2. So we would say the length of the edge of the block is about 3.2 centimeters. So it's real simple. You're going to need volume in order to use the mass formula. So now you know why we were doing this graphical approach. Because now we have a problem that we don't want to do by hand. We can just cheat and put it in the graphing calculator and find the point of intersection, which is going to give us a solution. Okay, I'm going to do one more problem, and I have about 7 minutes. So can I erase this? Anybody want to ask me a question about this? I'm going to do one more.
I have no questions.
Okay, can I erase this?
Yeah.
So this is going to be a similar problem. It has to do with the ball bearing, which is a ball. A ball is a sphere. So we're going to have to find the volume of a sphere. You can look it up on the internet or look in a geometry book. But what we have here is we have a sphere and let me read the problem. Okay, this is on page 2B. Estimate the radius of a steel ball bearing with a mass of 75 grams and a density of 7.82 grams per cubic centimeter. So like I said, to do this problem, we're going to need the volume in terms of the radius of a sphere. And don't ask me why I remember this because I hate geometry. It's 4/3 pi r cubed. So the mass in terms of the radius is the density times the volume. So the mass is 75 equal to the density, which is 7.82 times the volume of the sphere. And we're going to solve for the radius. So let's doctor this a little bit. Take 7.8 on your calculator, times 4 times and divide by 3. So multiply 7.82 times 4 times pi and divide by 3 and tell me what you get.
$32.75.
7.6?
Yeah, I'm sorry.
So under y sub 1, you're going to put 32.76 r cubed. See how hard this would be if we were doing it by hand? Under y sub 2, you're going to have the calculator draw a straight line through y equals 75. This right here is a cubic polynomial. So you're going to see part of it going like that. The other part is over here on the other board. You're going to find the point of intersection, which is something 75, and that right there is going to be your radius. So you would say something like the radius of the steel ball bearing is about whatever you find that X value to be. All right, that is the lesson for today. Like I said, tomorrow we're going to be working extensively in the Math Wizard teams on the review for lesson 5.1 test. And you should make sure you take a look at all this if you have any questions for me tomorrow. But we're going to be working in the teams tomorrow a lot. So anyone want to ask me about anything right now?
No, I understand it.
Okay, did anybody find the X value here so we can just write it?
1.32.
Yep, it's about 1.3. So you would say the radius of the ball bearing is about or approximately 1.3 centimeters. And that's correct. The radius of the steel bar bearing is about 1.3 centimeters. All right. Well, I hope you all have a nice day, and see you guys. I won't see you tomorrow. I'll see you on Friday, right? So I'll see you on Friday. Okay, and we'll spend all day Friday working in the Math Wizard teams. So. All right, you guys, have a good day. I will see you
Bye, Miss
Friday.
Birch.
Bye, guys. Have a good
Bye.
day. Bye, guys.